Hi, in this video, we're going to look at sampling techniques and misuses of statistics. This is likely going to be broken up into two separate videos just because it's a lot of content. What I want to start off with is first acknowledging that you should use the section 12.1 in our e-textbook to find these definitions and read about the example problems. I will talk through things, but it's always good to make sure that you're verifying and reading the content. The first thing I want to go over is just the definition of statistics. You've likely heard of statistics before. Perhaps you're a sports fan and you like baseball or basketball, football, hockey, etc., soccer statistics, or maybe you work with data. Perhaps you like to read the news and you see a lot of statistics in the news. So statistics is a method for collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. Some people say that statistics is an art. Sometimes people say that statistics is a science. It could be considered a little bit of both. And there's actually a lot of beauty within the numbers and statistics, and you have power to make inferences about different situations. So we're going to talk about two different types of statistics. We're going to talk about descriptive, words. We're going to talk about descriptive statistics, and we're going to talk about inferential statistics. First, with descriptive statistics, this uses data to provide descriptions of the population, either through numerical calculations or through graphs and tables. So this is literally used to describe populations, okay, using calculations or graphs and tables. Calculations. An example of descriptive statistics might be if we took our homework 1.1 average. So the population would be the homework scores for all students in Anna Castine's Math 1332 class. And then the descriptive statistics would be things that might show the mean, the median, the mode, the range, perhaps the standard deviation, things like that. This would show and describe what happened within our population of students on that first homework assignment. Standard deviation is typically used in inferential statistics, but we can get into that. Okay, so inferential statistics makes inferences and predictions about a population based on a sample of data from the population in question. So this is used to make predictions. Make predictions or generalizations about a population. So about population. So descriptive statistics actually describe the data that we have there. Inferential statistics is used to make predictions about an entire population based on a smaller sample. So I took statistics with a professor at TWU. I took two graduate classes on it, and he would always draw these little diagrams that show we have a population. There are in values in the population, and then we could have the population mean, we could have the population standard deviation. When we're talking about a certain variable X within the population, but in order to make predictions about the population, we have to look at a sample of size little n. And there would be a mean for that sample, there would be a standard deviation for that sample, and we're looking at that same variable. Okay, so inferential statistics is used to make predictions, and there are different ways to select your sample, and that's one of the things we're going to be looking at in this video, because we're going to be looking at sampling techniques. Some additional vocabulary, just in case these slip out of my mouth, is anytime we're talking about a statistic, we're talking about from a sample. Anytime we're talking about a parameter, that's talking about the population. So if you have the population standard deviation, that is an example of a parameter. If you have an example of the mean of the sample size in, that's an example of a statistic. Okay, one way to remember is population starts with P and so does parameter. Sample starts with S and so does statistic. So one of the methods for selecting a sample is to do random sampling. And random sampling is if a sample is drawn in such a way that each time an item is selected, each item in the population has an equal chance of being drawn, then we're dealing with random sampling. So there's no preference to certain items within the population. So we can consider the election from 1936. There was a magazine, Literary Digest, which surveyed people to see who would win the presidential election. They sampled 10 million names, which were selected from telephone books, car registration forms, and club membership lists. The survey results had Landon winning, with earning 57% of the vote. But in the actual election, Landon lost. He only received 38% of the vote, and Roosevelt ended up winning with 62%. So the question we can ask was their sample actually random? So thinking about the situation, if you have a telephone number, that means you have a phone. And if you have a car registration, that means that you own a car. And if you are part of a club membership, that means that you pay membership fees. So these select groups of people all have something kind of in common. They had the means in 1936 to own these items. I did a little checking up on some statistics, haha, and found that only 49 or 40.9% of Americans in the 1930s owned a phone, and only about 18.7% of Americans in 1936 owned a vehicle. Now that could be family vehicles, so perhaps they might have been surveyed, but that's a very low percentage of people. So, and then club membership fees, I don't have a number for that, but I can imagine if they're talking about like country clubs, there is a large part of the population that might not have been on the rosters for a country club. Did they survey women and perhaps African Americans and people who had not had the right to vote for very long? This might have skewed this data significantly. So, was their sample random? No, they picked a kind of elite group of people, people who own phones, people who own cars, and people who had the means to pay for club memberships. And so that is not a random sample. One remark I want to make is that they did sample a large number of people. They sampled 10 million names, but the population of the United States in 1936 was 128 million people. So that's about a little bit less than well, kind of significantly less than a tenth of the population. But that's a large number of people. The problem is that they they essentially had bias. They only polled people who essentially were wealthy. And during 1936, if you think about it, historically speaking, that's during and right after the Great Depression and the Dust Bowl. And so the wealthy only represented a very small portion of the population. Most people were struggling significantly during that time. We have a list here of the different types of sampling. Now we're going to focus on simple random systemic stratified cluster. And the last one we're going to look at is actually convenience. So we're not going to look at multi-stage, so I'm going to cross it out here. But we have already looked at simple random sampling So essentially it is, if you have a full list of the population, you choose a random selection where everything has an equal chance of being selected. So you could use like a random number generator, and like if you had everything, if you had people's names listed 1 to 100 and you had a random number generator run and pick 20 of those numbers assigned to people's names, that would be an example of simple random sampling. Everybody has a fair chance of being picked. It's also kind of like the lottery. Everyone has the same chance of winning based on the fact that they got to pick 5 random numbers for their lottery ticket. So then the next one we'll look at is systemic. And we start at random, and then at a point on the sampling frame, we choose every, and it says 10th, but I'm going to replace that with nth case. So that would be if you had people standing in a line and you were to ask every fourth person your survey question. Nobody gets preference because the way that they're already ordered determines who gets picked. So that's a systemic way to do it. It's consistent because you go 1, 2, 3, 4, ask your question. 1, 2, 3, 4, ask your question. 1, 2, 3, 4, the fourth person you ask your question. And so that could give you a good sample. And I put good in quotes, good sample. A stratified sample is when you sample, you choose your sample based on a certain, what they call strata. So it could be based on race or class or sex, and then random sampling. So I have an example of this, which I think makes it more clear. At TWU, I know that's not our school, but it's Texas Women's University. The population of that school is 90% women and 10% men. So if I had a survey that I wanted to do at TWU and I ended up asking 100 people my question, but 50 of them were women and 50 of them were men, that would not be an accurate representation of the population of the school. And so I might choose, if I wanted to survey 100 people, I might choose 10 from the men and 90 from the population of women. And that's stratifying the population into these different classes. Okay? Not class like wealth or whatever, but just like different sections. So that's stratified. And what it means when you stratify it is that you're trying to have your data look like your population. So you're not trying to manipulate your data. You just don't want somebody's voice or a population's voice to be louder or count more when they don't represent the majority of your population. So that's stratified sampling. In clustering sampling, instead of individuals being the sampling unit, subgroups of the population are used as a sampling unit. So the population is divided into subgroups, and then from the subgroups, which are known as clusters, those are randomly selected to be included in the study. Okay, so the clusters are usually already defined. And so there's not like a post description or post change to what the clusters are. Sometimes it has to deal with like geographic regions or households or other types of clusters. But then it's sometimes used because it's more efficient than simple random sampling, because if the study takes place over a wide geographical region, it might take a lot to get individual samples, but if you have subgroups, you're able to get the same information, but from a cluster of people instead of just one individual. The last sampling method we're going to discuss is convenience sampling. Now, first thing I want to say about convenience sampling is that it is a biased way to sample. When we have good samples, we want to avoid bias at all costs, but sometimes this is the only way you can do it. So convenience sampling is the easiest method to sample because participants are selected based on availability and their willingness to participate. So this would be a situation where maybe every single TCC student was emailed a survey. Now you can either take the survey or you don't take the survey. So you have a willingness, if you take the survey, to participate in that selection. But if you choose not to, you're not part of the selection. So that's an example of convenient sampling. We can get useful results from this, but they are often prone to bias because um, let's say TCC wanted to lower tuition. That'd be awesome, right? It's not happening. Don't get your hopes up. But let's say they wanted to lower tuition and they sampled or they sent the survey out to students only. Well, students are going to want their tuition lowered. So they have a bias. They already know what they want to happen. Whereas if they were to send um, the survey to every person who pays property taxes in Tarrant County, they might be biased against that because if tuition is lower, then their taxes would increase to cover the difference in taxes or in tuition. So in convenience sampling, oftentimes there's a drive for people to participate if they have a positive reaction or an extreme negative reaction to the question that's being asked. Okay, so there is a lot of bias oftentimes because the people who volunteer to take part may be very different from those who choose not to. Okay, they call that volunteer bias. And the sample may not be representative of other characteristics such as age or sex. So that is another type of sampling that we might see. Again, it's not one of the ones that we prefer because it does hold with it a significant amount of bias. So let's look at some examples of sampling techniques and determine which one was used to figure or to obtain the sample. So the first one is viewers of the CBS network are classified according to age. A random sample of viewers from each age group is selected. So the classification according to age, that gives us a strata, a grouping, right? And a random sample of viewers from each age group is selected. This is an example of stratified sampling. The next one, every 10th Samsung television coming off the assembly line is checked for defects. That 10th, picking every 10th TV to check for defects, is systematic. You have a system on how you select the people. It's the TVs. It's every 10th TV. A state is divided into counties. A random sample of 12 counties is selected. A random sample from each of the 12 selected counties is selected. That's very redundant. I apologize. But essentially, these counties represent a cluster, and 12 clusters are selected. This is cluster sampling. Next we have, oh my goodness, I'm sorry, y'all. The Food and Drug Administration randomly selects 5 stores from each of 4 randomly selected sections of a large city and checks food items. It's food items. Oh my goodness, food items for freshness. These stores are used as a representative sample of the entire city. So we have 5 stores from 4 randomly selected sections of a large city. So essentially, the city is broken into 4 pieces, and they pick 5 stores from each of the 4 sections of the large city. That is an example of cluster sampling. A door prize is given away at a home improvement seminar. Tickets are placed in a bin and the tickets are mixed up. Then a ticket is selected by a blindfolded person. So this is an example of everybody has an equal chance. Everybody whose name is in the bin has an equal chance of being picked. And so this is random sampling. Random. Then we have the businesses in Virginia City, Nevada are grouped according to type: medical, service, retail, manufacturing, financial, construction, restaurant, hotel, tourism, and other. A random sample of 10 businesses from each type is selected. So this is broken up into stratas or groups. And so this would be stratified sampling. The first 30 adults leaving a theater are asked how much money they spend per week on entertainment. This is an example of convenience sampling. You're standing outside the movie. They clearly enjoy entertainment. They're not an unbiased group, and it's convenient for you to stand there and ask those first 30 people leaving. For H, every 20th person in line is to buy or in line to buy tickets to a concert is asked his or her age. That is systematic. Bingo balls in a bin are shaken and then the balls are selected from the bin. I'm guessing that they're randomly selected either by a machine or by a person who might be blindfolded. That would be random. Lastly, the Student Senate at the University of North Carolina is electing a new president. The first 25 people leaving the library are asked for whom they will vote. That is convenience. There's no method into how you're picking them. They're just people leaving the library. They're conveniently there. You pick them conveniently. You don't pick them randomly. It's every one of those 25 people who come out in a row gets asked for whom they will vote. So that's a convenience. Also, you're picking a sample of people who went to the library. If you were going to do something like this, you might want to be like, I'll have a person surveying the library, a person surveying in the food cafeteria, I'll have a person surveying in the dorms, I'll have a person surveying, like phone calling, making phone calls to students who live off campus. Like there would be the need to have a much wider sample than just those 25 people who came out of the library. We're going to take a look at misuses of statistics in the next video. Hopefully that will be significantly shorter. You'll want to make sure you read the pages 728 and 729 to understand the different misuses of statistics, but make sure you watch the second video on 12.1.